Hello everyone, my name is Yu Yuan. This is my partner Kara. Today we are going to talk about our project Emojimotion. Let me give a brief introduction. We use emoji every day when texting and posting on social media. For example, first day at school with a smiling face or rolling eye face have opposite emotion. Therefore, we came up with our project Emojimotion. It predicts the emoji based on both the sentence meaning and will let the users to choose their emotion. For example, anger, anticipation, joy, etc. And this is the basic structure of our project. It can be divided into two parts. The first part takes sentences as inputs. It passes through a model, and the model will generate a list of top 15 emoji by sorting the output logics. The second part of Emojimotion takes users' choice of emotion as input, and it's for every emoji in the top 15 list from part 1, we find the corresponding emotion score and process the output logic, and we combine it together. The final output will be the top 3 possible emoji.
So we implement Twitter API to get the raw tweet dataset, and we select 54 emojis and scrap 5,000 tweets for each emoji. So we will use this dataset to train the model to predict emoji based on the contextual meanings. And the second part, we use the Emotag dataset. It's an open source dataset, and it contains the scores of emotion for each emoji. And it's trained scores, so we directly combine it with the context score we get from the part 1 to predict the final emoji. And in the data processing stage, we first remove the duplicates and lowercase the text, and we remove the noises in the text. And if the length of the text is smaller than 4, we delete these tweets as well. And the final data set will be 2,000 tweets for each emoji. There's an unusual issue for our raw data set. So when we scrap tweets using the API, we already set the search language as English, but we found some tweets still contain the foreign words in the text. But this issue is resolved in the data processing stage. And for the trend test split, we use Saturify to preserve the same proportion of examples of the class.
For our baseline model, we simply feed the word embedding average to a classifier layer. And our main model, we use the pre-trained BERT and with a classifier head. We choose to use the pre-trained BERT case on case, which has 12 layers and 110 million parameters. We use Gradio for demonstration. And this is our quantitative result. As we have 54 classes and one sentence could have a few reasonable emoji, we choose top 8 accuracy as our evaluation metrics that will mark the prediction as correct if the true label in the top exists in the top 8 result. To find a good model, we fine-tune the pre-trained BERT model by freezing different number of layers. It turns out that we have the best result when we freeze the first 6 layers. We also try to reduce the number of classes to 30, and we get a higher accuracy. However, we still choose the 54 classes as we wanted to provide our user with both wide variety of emojis and a model with reasonable accuracy. As can be seen, our best BERT model has a much better performance than the baseline model. For the qualitative result, in terms of our baseline model, if we input, let's grab a cup of coffee after class with a joy as emotion, it has some happy faces show up. And if we input sadness as emotion, it has a few sad faces. For our BERT model, if we input the same sentence with joy as an emotion, the most possible emoji will be a cup of coffee and 2 happy faces. With the sadness as emotion, the most possible emoji will be coffee, skull, and a flash face. It can be clearly seen that our best BERT model has a much more better performance than the baseline model, and it makes more sense.
So our baseline model accuracy actually is better than we expected, but it also makes sense as we are using the largest dimension of glove embedding. And the bird accuracy is, we also think it's good enough as it reaches 56% among the 54 class. So our surprising finding is that if we unfreeze all the bird layers, the top one accuracy is higher than freezing all the bird layers except the classifier layer. And for the future work, it will has many manual work. So for our current emoji labels, there are some similar emojis. For example, we have 8 different hearts. So in the future, we can choose emoji more diversely. And more work could be done for the data processing. So for example, here in the figure, the highlighted tweets are ads, and the sentence do not make sense, but it needs human sense to identify to delete. And our current tweet data set only has text and emoji. So the ways to combine the emotion score and the context score are not trained. If you want to add emotion for each tweet in the future, it will also take some time. So next we will show our demo. So for example, what are you doing? It can be used in many circumstances. So when 2 people are arguing, it will be some angry face here. And if it's like joy, yeah, the outputs will also come out the happy face. And yeah, yeah, I just want.
Okay, thank you.
Okay.